from that of water. So if you do that correctly, your answer will be minus 327 joule per Kelvin per mole. The entropy change for this reaction is highly negative because 3 gaseous molecules are being converted into 2 liquid molecules according to the drive towards higher entropy. The formation of water from hydrogen and oxygen is an unfavorable reaction. In this case, the reaction is highly exothermic and the drive towards a decrease in energy allows the reaction to occur. So the negative entropy also shows that the reaction is exothermic. So here we want to look at what we call spontaneous reaction. When we say a reaction is spontaneous, it doesn't mean that the reaction is fast. A spontaneous reaction is any reaction that can proceed to give us a product. Even if the reaction is slow, once it can actually form a product on its own, then it is spontaneous. So say reactions are favorable when they result in a decrease in enthalpy and an increase in entropy of the system. Please, I want you to take note of this place very well. This point is very important. Anything that will make a reaction to occur, a reaction that can proceed to form a product, this place is very, very important. That's why I say you should take note of it. What will favor such a reaction is that there must be decrease in enthalpy and then increase in entropy. Decrease in enthalpy and increase in entropy. That is what can make a reaction to be favorable. That is, the enthalpy must be exothermic in nature. It must be exothermic in nature, low temperature. Why? Then the rate of disorderliness in that particular reactor must be very, very high. That is just the meaning. So enthalpy will be negative, while the entropy will be positive. Then that will make the reaction to be favorable. When both of these conditions are met, the reaction occurs naturally. So once the reaction is favored, they can go on their own to form a product, then it is spontaneous. So a spontaneous reaction is a reaction that favors the formation of product and the condition under which the reaction is occurring. So a roaring bonfire is an example of a spontaneous reaction. Yes. So since it is exothermic, there is a decrease in the energy of the system. Remember, energy is enthalpy. Then there is a decrease in the energy of the system as energy is released to the surroundings as heat. You know, when you are burning things, you feel the heat. That means that particular thing you are burning is giving out heat to the surroundings. So released to the surroundings as heat. The products of a fire are composed partly of gases such as carbon dioxide and water vapor. Now the entropy of the system increases during a combustion reaction. The combination of energy decrease and entropy increase dictates that combustion. So the combustion reaction is also a spontaneous reaction because there will be decrease in energy of that reaction and then the entropy will increase. So that will favor the reaction. So you can call such that a spontaneous reaction. Now the other one, when we talk of a non-spontaneous reaction, a non-spontaneous reaction is a reaction that does not favor the formation of product at a given set of conditions, just the opposite of a spontaneous reaction. So in order for a reaction to be non-spontaneous, it must be endothermic. So vice versa. If we say a reaction will be spontaneous if there is decrease in enthalpy and increase in entropy, then that means for a reaction not to be spontaneous, then there will be increase in enthalpy and decrease in entropy. So we say in order for a reaction to be non-spontaneous, it must be endothermic, accompanied by a decrease in entropy or both. Our atmosphere is composed primarily of a mixture of nitrogen and oxygen gases. One could write an equation showing these gases undergoing a chemical reaction to form nitrogen monoxide. That is your nitrogen reacting with oxygen there to form a nitrogen monoxide. So in this case, that is nitrogen 2 oxide. Fortunately, this reaction is non-spontaneous at normal temperature and pressure. It is a highly endothermic reaction with a slightly positive entropy change. So you see, the condition does not favor the reactions to be spontaneous because the energy is very, very high, the temperature is high, which makes it endothermic, and then the entropy is not that high enough that can favor the reaction. So nitrogen monoxide is capable of being produced at very high temperature and has been observed to form a result of lightning strikes. So one must be careful not to confuse the term spontaneous with the notion that a reaction occurs rapidly. I've said that one earlier. A spontaneous reaction is one in which product formation is favored, even if the reaction is extremely slow. I've told you. So don't just think that when you say a reaction is spontaneous, what will come to mind will be, oh, that reaction is very, very fast. No, it's absolutely wrong. So when you say a reaction is spontaneous, that means that the reactant can naturally proceed to form a product. The conditions favors the reactant to form a product, and I told you that such condition is that there will be decrease in enthalpy and increase in entropy. So if you look at this one here now, we say a spontaneous reaction is one in which product formation is favored, even if the reaction is extremely slow. Now let's look at this example. A piece of paper will not suddenly burst into flame, although its combustion is a spontaneous reaction. What is missing is the required activation energy to get the reaction started. So if the paper were to be heated to a high enough temperature, it will begin to burn, at which point the reaction could proceed simultaneously until completion. Now, that is not about entropy. Then we'll go to free energy. Many chemical reactions and physical processes release energy that can be used to other things. When the fuel in a car is burned, some of the released energy is used to power the vehicle. Now, free energy is energy that is available to do work. The energy available to do work is called free energy. Now, spontaneous reaction release free energy as they proceed. Remember, we said for a reaction to be spontaneous, it must be exothermic. And exothermic gives out energy. So, recall that the determining factors was spontaneity of a reaction are the enthalpy and entropy changes that occur for the system. So the free energy change of a reaction is a combination of enthalpy change and then entropy change. The combination of enthalpy change and entropy change is what will give us free energy. Now, this is what we have here now. The delta G, this gives free energy equals to change in enthalpy minus temperature multiplied by change in entropy.